Now, on to my final example on solving equations. So I have to isolate x in the following equations with divisions on both sides. And we also have a condition where x must be different from 0 and c plus x must be also different from 0. Because if we do not have this condition here, we will have a division by 0. So it's just to make sure that we have a proper math problem here. So you don't have to deal with this. It's only to have a proper math problem. So when you have fractions on both sides, there's a special trick that is called cross multiplication. So you can just multiply like this. So you have to multiply numerator with denominator and numerator with denominator here. But before doing that, you have to put the invisible brackets, because when you have an expression like this, it means that all of the numerator is divided by all of the denominator, just to make sure that you do not split anything. Same thing here. All of this is divided by all of that. And now you can cross multiply. So I'll multiply this one with this one. So it's going to be AB multiplied by X. This one multiplied by this one. And it's going to be this one multiplied by this one. So it's going to be D minus Y multiplied by C plus X. C plus X. And this is a much simpler problem because now we do not have any fractions. What are we going to do? We're going to just get rid of the brackets. There's no plus or minus here, so we can just rewrite this as a bx. So we don't have to distribute anything in this. On the other side, though, we will have to distribute the d on both terms and the negative y also. So it's going to be dc plus dx minus yc minus yx. Let's just do that again. dc dx negative yc negative yx. So now we're done with the expanding of our brackets. Now we have to isolate x. So now I'm going to bring all the x's on the left side. You can also choose the right side, but then you'll have to bring the constant number on the left side. So I'm going to put all the x's on that side. So I'm going to bring that dx here. Bring that negative yx here. It's going to change the signs of the terms. So you got to be very careful. It's going to become yx positive because it was originally negative. That dx is going to be negative dx because now it's going to be negative, plus that abx, which was already on the left side, so I do not change its sign. And on the right side, it's going to be dc minus yc. So stays on the right side. I use the special trick. I factor out my x. So now I have x as a common factor of y minus d plus ab, and all of that is going to be equal to dc minus yc. And I am almost done. All I have to do now, since my x is multiplying this bracket, all I have to do now is divide the expression on the right side by this bracket. So I'm going to do it right underneath. So it's going to be x that is equal to dc minus yc. So I rewrite my numerator and I divide that by the bracket here, y minus d plus ab, like that. So now I have isolated my x, and if I want to be even more polite with my final answer, I see that both of those terms have C as a common factor. I can even factor out my C. So that's what I'm going to do here. I'm going to factor out that C. So what's going to be left when I factor out the C at the numerator? It's going to be D minus Y. So I'm going to have D minus Y over the same expression. So it's going to be Y minus D plus AB. So I can even factor out my C if I want to be even more polite. So I'm done. Thanks for watching.